Good morning and welcome to the 2014 Sochi Winter Olympics. Today we will be discussing the ski jump event to learn about the physics behind the sport. First, let's take a look at the athletes. Several of the notable competitors on this year's U.S. team included Nick Farrell, Nick Alexander, Peter Frenette, and Anders Johnson. For the first time in history, women were also allowed to compete in the sport. The USA was represented by females Jessica Jerome, Sarah Hendrickson, and Lindsey Vonn. For those of you who are unfamiliar with the sport of ski jumping, here are some of the basics. In ski jumping, competitors ski down a steep takeoff ramp in a crouched position and then fly off the ramp leaning forward with their hands at their sides, attempting to go as far as possible. Here are some examples of ski jumpers in action. Ski jumping consists of 4 different events: men's and women's individual normal hill, men's individual large hill, and men's team competition. As for scoring, each hill has a target called the calculation point, or K point, where skiers aim to land at or beyond. 60 points are awarded for reaching the K point, with points added for landing beyond or subtracted for falling short of the line. In addition, 5 judges can award up to 20 points for the style of the skier based on steadiness of the skis during flight, balance, good body position, and landing. The highest and lowest style scores are disregarded, and the other 3 are added to the distance score, creating the final score for the skier. When weather conditions are not equal for all skiers, point values can be adjusted to keep it fair for all competitors. The skier with the highest combined distance and style score wins the competition. Now that you know more about ski jumping, let's explore the physics behind the sport. The first principle that comes into play in ski jumping is friction. When flying down the ramp, the amount of friction between the skier's skis and the snow is very important in determining how fast he or she will be able to go. As the skier flies down the ramp, their potential energy at the top of the hill will be converted into kinetic energy as they travel down the hill. However, some of this energy is converted to heat energy due to friction. The skier's goal is to reduce the amount of friction, or resistance, between their skis and the snow. In order to do this, skiers coat the bottom of their skis with wax. Another factor in reducing friction is the shape and design of the skis, which vary based on snow quality. Here's an example of physics in our daily world. When I roll the cylinder on the towel, it will not travel as far as when I roll it on the granite. Another important physics principle involved in the ski jump is air resistance. On the way down the ramp, skiers crouch into a position with their chest parallel to the ground, head down, and arms reaching back behind them. This position allows skiers to reduce the amount of air resistance on their bodies, allowing them to gain speeds of well over 60 miles per hour. Their goal is to reach the highest possible speed before they launch into the air so they can remain airborne for as long as possible, and thus go as far as possible. However, after the takeoff, skiers must use air resistance in a different way. Once they are airborne, a skier must harness air resistance by leaning forward and spreading his skis in a V formation. This allows the skier to glide through the air in a parabolic path. Another physics principle involved is momentum. After flying down a ramp at more than 60 miles per hour, launching into the air, and traveling the distance of almost 2 football fields, the landing of the ski jump is critical to the safety of the jumper. In order to decrease the force on the body at the time of collision with the ground, the skier must bend their knees. This increases the span of time over which the contact occurs, thus reducing the force because of the law of conservation of motion. This technique must be used in order to protect the ski jumper's body. Thank you for joining me today, and I hope you have enjoyed learning about the sport of ski jumping and the physics behind it.